Chapter 8 practice exam, number 4. This is a multiple choice problem. We've got a satellite S in elliptical orbit around planet P, as shown, it should be to the left. It used to be above. I moved it to save space. R1 and R2 being closest and farthest approaches, respectively, from the center of the planet. Satellite has a speed v1 at its closest distance. I want to know what the speed is at its farthest distance. So the thing is, there's no forces out here except for gravity. Gravity is always going to be pulling right along the radius, so it's not going to provide a torque to this thing, because if you were to try and figure out what the torque was, you'd be doing the force of gravity times the radius times the sine of 0, which is 0. So there is no torque, which means there is no external torque, which means there is, angular momentum is conserved. So what I've got here is angular momentum has to stay the same. And angular momentum is I omega. So I'm going to have initial I times initial omega should equal finals of those as well. Okay? You might be thinking, okay, where are these R's and these V's coming from? Well, they're coming from this. I for a point, and that's how we can pretend a planet or a satellite is a point, because their personal radius is much smaller than the radius to the thing you're orbiting. For a point, it's mr squared. So this is going to be r1 squared. And then omega is v over r in general. So omega I is going to be v1 over r1. And I do the same kind of thing on the other side, mr2 squared times v2 over r2. Bunch of stuff cancels, like this r2 cancels one of those, this r1 cancels one of those, the m's go away. So now I just have r1 v1 equals r2 v2. Solve for v2, and you get r1 v1 over r2, which is A.